The narrative surrounding the Su-57, Russia's ostensibly premier fifth-generation stealth fighter, began with a crescendo of ambitious pronouncements, painting a picture of an aerial platform destined to redefine Russian air power and project its technological prowess onto the global stage. It was conceived and promoted as a formidable counterpoint to the United States' own advanced combat aircraft, specifically the F-22 Raptor and the F-35 Lightning II, aircraft that had already established a new benchmark in aerial warfare capabilities. The design philosophy underpinning the Su-57 promised a multifaceted, exceptionally advanced multirole fighter, engineered not merely to compete but to achieve dominance in contested airspace through a sophisticated amalgamation of stealth characteristics, the ability to sustain supersonic flight without the use of afterburners, supercruise, and an array of potent, next-generation avionics. This aircraft was intended to be the vanguard of a new epoch for the Russian Air Force, a tangible demonstration of their capacity to engineer and deploy a genuinely sophisticated, state-of-the-art fighter jet capable of equaling, and in certain projected scenarios, even eclipsing the technological achievements of Western air forces. However, as the years have unfolded since its initial unveiling, the Su-57's journey has been characterized by a persistent accumulation of significant obstacles and disappointments, spanning both the challenging developmental phases and its limited real-world operational exposure. These accumulating issues have progressively eroded its initially vaunted reputation. Instead of fulfilling the lofty expectations and validating the grand promises made at its inception, the Su-57 has increasingly come to embody the difficulties encountered when ambitious technological aspirations collide with the harsh realities of complex engineering, economic constraints, and evolving geopolitical landscapes, transforming it into a symbol of grand objectives that ultimately failed to fully materialize in the manner originally envisioned and widely publicized. From its very genesis, the Su-57 program seemed to be shadowed by an array of persistent difficulties. The foundational development work commenced in the early years of the 21st century, driven by the Russian government's strategic imperative to field an aircraft that could stand as a credible peer to the advanced fighter platforms being developed and deployed by the United States. The aircraft achieved its maiden flight in the year 2010, an event that was met with considerable optimism, and early assessments from various quarters suggested that the Su-57 indeed possessed the intrinsic potential to mature into a truly world-class aerial combat system. Nevertheless, despite this apparently auspicious beginning, the program soon found itself mired in a protracted sequence of delays, unforeseen technical impediments, and critical shortfalls in funding. The Russian defense industrial base, already operating under considerable strain due to a confluence of broader economic pressures and complex geopolitical entanglements, proved to be inadequately equipped to facilitate the rapid technological maturation and large-scale production necessary for a genuinely competitive fifth-generation fighter program to thrive and meet its aggressive timelines. A particularly significant and persistent impediment to the Su-57's smooth development and operational readiness revolved around the critical issue of its propulsion systems, specifically its engines. The aircraft was originally slated to be powered by the Izdeliye 30 engine, a powerplant conceived as a next-generation design intended to deliver substantially superior performance characteristics, including enhanced fuel efficiency, a greater thrust-to-weight ratio, and consequently, improved overall agility and kinematic performance. However, the development pathway for the Izdeliye 30 itself encountered substantial delays, forcing the Su-57 prototypes and early production airframes to rely on older engine models for a significant portion of their flight testing and initial operational integration. These older engines, while fundamentally functional and capable of powering the aircraft, were inherently incapable of endowing the Su-57 with the full spectrum of performance capabilities that were central to its design specifications and its intended operational advantages, particularly concerning its ability to achieve sustained supersonic cruise speeds efficiently and its overall combat radius and fuel economy. The Izdeliye 30 engine, even when it eventually reached the stage of being tested on Su-57 airframes, was reportedly still not fully matured or certified for widespread operational use when the aircraft was first introduced in very limited numbers into service, thereby effectively preventing the Su-57 from demonstrating or realizing its complete performance potential, especially in areas crucial for a fifth-generation platform. The ambitious Su-57 program also found itself grappling with the severe repercussions of Russia's overarching financial difficulties. Subsequent to the 2014 annexation of Crimea and the imposition of extensive international sanctions that followed, the Russian economy experienced a period of significant contraction and stagnation, leading to substantial reductions in the national defense budget. The Su-57 project, already a technologically demanding and financially burdensome undertaking, was directly and negatively impacted by these fiscal retrenchments. Consequently, Russia's defense industry was compelled to significantly curtail its production targets and found itself unable to sustain the necessary level of investment required to manufacture the aircraft in the quantities that had been initially planned and projected. This resulted in a stark contrast while nations like the United States and China were moving forward with the mass production and widespread deployment of their own fifth-generation aircraft, such as the F-35 and the J-20 respectively. Russia was only able to field a very small number of Su-57s. This severely limited production volume meant that the Russian Air Force could not effectively integrate the Su-57 into its broader operational doctrine or establish a meaningful combat force around it, leading the jet to function more as a symbolic representation of Russia's latent technological capabilities rather than as a truly effective and widely available combat aircraft. Despite these multifaceted developmental and production challenges, one of the most vigorously promoted and highly anticipated attributes of the Su-57 was its purported advanced stealth technology. Stealth, a term encompassing a suite of design features and materials intended to minimize an aircraft's detectability by enemy radar and other sensor systems, has become an indispensable characteristic for modern fighter jets seeking to survive and operate effectively in contested environments. The Su-57 was consistently touted as possessing superior stealth capabilities that would theoretically enable it to outmaneuver and decisively engage older, less stealthy aircraft, and even hold its own against contemporary Western stealth fighters like the F-22 and F-35. However, independent analyses and assessments of the Su-57's radar cross-section (RCS), a critical metric that quantifies how readily an aircraft can be detected by radar, have consistently suggested that its stealth characteristics may not be as advanced or as effective as originally claimed by Russian sources. While the Su-57 undeniably incorporates certain stealth-shaping design elements, such as blended wing body contours, internal weapons bays, and the use of radar-absorbent materials in some areas, it has drawn considerable criticism, particularly for design features like its relatively conventional and less shielded engine air intakes, which are considered to be significant contributors to its overall radar signature, especially from frontal aspects. Furthermore, the specific shaping philosophies, the precision of its manufacturing tolerances, and the advanced composite materials employed in the Su-57's construction are widely believed by many Western analysts not to be as sophisticated or as thoroughly optimized for low observability as those utilized in aircraft like the F-35, whose stealth design is generally regarded as being more comprehensively integrated and effective across a wider range of radar frequencies and aspect angles. Consequently, a significant body of expert opinion posits that the Su-57's level of stealth might prove insufficient to render it truly undetectable or survivable in high-threat airspaces, especially when facing the advanced and continually evolving radar systems and integrated air defense networks operated by NATO and other potential adversaries. Avionics systems represent another absolutely crucial pillar of any modern fighter aircraft's combat effectiveness, and in this domain, the Su-57 has also encountered pointed criticism and unfavorable comparisons. The aircraft was originally envisioned to be equipped with a suite of cutting-edge sensors, including highly advanced radar systems purportedly capable of tracking a multitude of targets simultaneously and providing its pilots with unparalleled situational awareness. However, numerous aerospace and defense experts have contended that the Su-57's avionics suite, particularly its primary radar and sensor fusion capabilities, may not be on par with the sophisticated systems integrated into leading Western counterparts, most notably the F-35. The U.S. F-35, for instance, is outfitted with the AN/APG-81 Active Electronically Scanned Array (AESA) radar, which is widely acknowledged as one of the most advanced and capable airborne radar systems currently in operation worldwide. This system provides exceptional target detection and tracking performance, robust electronic warfare capabilities, and is deeply integrated with the aircraft's myriad other sensors to create a comprehensive and fused picture of the battlespace for the pilot. The Su-57, in contrast, is believed by some analysts to utilize radar technology that, while advanced by some standards, may be based on slightly older design principles or possess certain limitations in terms of processing power, detection range against low observable targets, or its ability to seamlessly integrate data from diverse onboard and off-board sources. This perceived gap in avionics sophistication, particularly in the critical areas of sensor performance and data fusion, could potentially place the Su-57 at a distinct disadvantage in complex engagements against Western fighters that benefit from more mature and extensively networked sensor suites, impacting its ability to detect, track, and engage threats effectively. Beyond its documented technical shortcomings and developmental hurdles, the Su-57's exceedingly limited and largely uncorroborated combat record has served to further amplify doubts regarding its genuine operational effectiveness and its ability to perform as advertised. The jet has reportedly participated in a small number of sorties during the Syrian civil war, where its deployments were largely confined to relatively low-risk missions. Seemingly orchestrated more for the purpose of demonstrating its presence and purported capabilities to a domestic and international audience, a form of armed propaganda, rather than for engaging in demanding combat operations. Crucially, during these limited deployments, the Su-57 is not known to have engaged in any air-to-air combat, particularly against peer or near-peer adversaries, nor was it subjected to the kind of high-intensity, complex combat scenarios that would truly test and validate its advanced design features, such as its stealth, maneuverability, and avionics. The absence of any participation in demanding dogfights or sophisticated beyond visual range engagements means that there is a significant lack of empirical evidence to substantiate how the Su-57 would actually perform when pitted against modern, well-equipped fighter jets in a real-world, high-stakes conflict. Without a substantial and verifiable combat history under challenging conditions, it remains exceedingly difficult to accurately gauge the Su-57's true performance envelope and its overall combat utility, which has understandably led to widespread skepticism about whether the jet could genuinely meet its ambitious design objectives and operational expectations in a demanding, peer-level combat environment. As the situation currently stands, the Su-57 represents a stark departure from the revolutionary, paradigm-shifting fighter aircraft that Russia had initially envisioned and vigorously promoted. While it may still possess some inherent potential and could eventually mature into a more capable platform, the aircraft's development trajectory has been so extensively marred by a litany of deeply ingrained issues, spanning technical, financial, and production domains, that it becomes increasingly challenging to view its future prospects with genuine optimism or to take its claims of superiority seriously. The fighter has consistently drawn unfavorable comparisons to Western fifth-generation stalwarts like the F-22 and, particularly, the F-35, both of which have been successfully developed, produced in significant numbers, and are now thoroughly integrated into the operational doctrines of Western air forces, with hundreds of units deployed and operating globally. Meanwhile, the Su-57 remains restricted to a mere handful of operational or near-operational aircraft, and it appears highly improbable that it will ever achieve the kind of mass production originally anticipated by Russian planners, which is essential for it to become a truly strategic asset. Even within Russia itself, there are palpable undercurrents of doubt and reassessment concerning whether the jet can realistically live up to the lofty promises that accompanied its inception. Indeed, in certain segments of the international defense and aerospace community, the Su-57 has, unfortunately for its proponents, become something of a recurring object of derision, frequently cited as an example of overreach, and often mocked for its protracted delays, its apparent technological limitations when scrutinized against its peers, and its conspicuous lack of verifiable operational success or meaningful combat validation. What was once heralded with great fanfare as a potential game-changer poised to elevate the capabilities of the Russian Air Force to new heights is now widely perceived by many informed observers as a prominent symbol of unfulfilled potential and unmet expectations. Despite the impressive and often assertive claims made regarding its advanced capabilities, the Su-57 is demonstrably hampered by a cascade of interconnected design deficiencies and operational impediments that have collectively prevented it from living up to the considerable early hype and strategic importance attributed to it. The jet's severely limited production numbers, its conspicuous absence of a proven and demanding combat record, and its acknowledged technological shortcomings, particularly in critical areas like stealth and advanced avionics, collectively signify that while it may eventually carve out a niche role within Russia's diverse air fleet, it will almost certainly never evolve into the transformative strategic asset or the global export success that was originally envisioned at the outset of its ambitious journey. Instead, the Su-57 serves as a potent and sobering reminder of the immense complexities and profound difficulties inherent in the development of truly advanced, cutting-edge military technologies, particularly for a nation facing significant economic pressures and technological hurdles. It has, in effect, become an emblem of Russia's ongoing struggle to achieve the kind of decisive technological leap forward that would be necessary to genuinely rival the established technological supremacy of the West in the critical domain of advanced air combat capabilities. At this juncture, the Su-57 remains largely a cautionary narrative, a compelling testament to the formidable array of challenges encountered when attempting to develop and field sophisticated modern military technology within an operational environment fraught with an intricate web of financial constraints, shifting political priorities, and persistent technological obstacles. Until such time as it can conclusively prove its mettle in demanding combat scenarios, and until its numerous well-documented developmental and performance challenges are comprehensively addressed and demonstrably overcome, the Su-57 will likely continue to be viewed through a lens of disappointment, falling considerably short of the bold and ambitious promises that were so confidently articulated for it at the dawn of its development program. For the foreseeable future, it seems destined to exist as a fighter jet perpetually caught in a state of being almost ready, almost capable, seemingly unable to decisively break through the barrier of its latent potential and graduate into the realm of true, widely acknowledged, and operationally significant success on the global stage of advanced military aviation.